Okay, I think we're almost live. Cool. Okay, we're live. I've told the Discord channel about this. I'm going to move this up to the left corner so you guys can go ahead and check out the prompt. And we got a couple of drawings already that I've made. You know what? I took a picture as well to help me. So I don't know, you guys can't really see that super well. But I've already kind of mapped, I've already kind of done some pre-work again because I like to try and make sure that I cover everything. But there's something you guys can look at while waiting. What else do I need to do? Oh, I need to pull up the chats. I'm gonna mute myself here for a couple minutes. I basically just think out loud for the first 15 minutes sometimes. Okay, I think we can go ahead and kick things off. I can go ahead and kill this thing. I saw there was a couple of questions in the chat. Let's go ahead and try to go through those really quickly. Is my screen frozen up or what is the deal with this? Oh, the scroll bar is not working phenomenally. Okay. You know what? I think I know how to. There. Okay. Now I got the chat working again. There's a question about problem order after finishing DDIA. Yeah, I just recommend. Oh, this is further on. So it's the first question was which problem order to go off of when you're done with DDIA. Just the standard grokking ones are good. Apart from DDIA and system design books by Alex Shu, grokking, Stanley Chang, anything else you use to prepare for system design like Medium blogs, etc. So I have that that compilation picture that I think I've posted a couple of times now. It's on the community tab of my channel. It's in the README of my Discord group. Well, I haven't posted a link to that yet. I should post that in the live chat. I'll make sure to do that before the end. Yeah. Time like counter. You know what? Let's go ahead and jump into the problem. If you have any other general questions for stuff unrelated to the topic for today, feel free to drop it in the Discord channel or in the comments below the video. I want to focus on the topic for today, though, rate limiter. I actually have quite a few different approaches for this. It's actually a little bit intimidating to handle these very standard problems sometimes because there's sometimes just so much coverage on them that I like to cover a lot of approaches, and then consequently trying to cover all of them means that I end up with stuff like this where I've got like 5 different approaches, 6. I've literally got like 6 different approaches that I'm going to try to cover today. Yeah. So these were pretty solid. I have 5 different system design problems books. And so at least 3 of them actually had coverage of the rate limiter problem. One of them was in Alex Shu's book. Grokking has it. Stanley Chang's book has it. I do actually recommend this book. It's actually pretty solid. It's actually a little bit better than Alex Shu's first book for quite a few problems. Alex Shu's first book did actually have some pretty solid coverage of this problem. I think he had like 5 different algorithms for handling rate limiter, while grokking only had 2. I'm only going to cover 2, which is just the fixed window and the sliding window approach. There was this leaky bucket approach. I'm actually not a fan of that, but I might just misunderstand it. We can talk about that later as we're getting into it. Just some background on this problem. If anyone's not familiar with it, it's just a standard rate limiter component that you plug into your architecture, where you're just trying to limit the user to a certain number of actions within a time frame. Depending on the use case, it's going to vary how you're going to want to design it. And so like the most standard approach is, of course, going to be denial of service attacks. That's what you would most likely think of. And so that would require a very different approach than if you're just trying to like do stuff like throttling of like downstream services, or if you just want to limit your users to only doing like 20 accounts per day, or like, hey, you can only send 1 message per second, just stuff like that, as opposed to a denial of service attack where you're talking like tens of thousands or hundreds. That could literally be like tens of millions of hits per second. You would take a very different approach for DDoS protection as opposed to something like this, something a little bit more like rule enforcement. So depending on which use case you're trying to handle is going to result in a very, very different approach. Some of them, it's like you can get away with like you actually specifically want an exact count. It could be like a budget kind of thing where it's like, hey, the user can only do this operation, this calculation operation, we're only going to let them call ChatGPT 20 times per day, for example. So you would want an exact count of 20 per day, as opposed to DDoS, where it's a very flexible number that can be off by like 5 or 10%. You don't really care. It's just a ballpark thing. So there's two really big standard things to, are there any questions before I try and jump into some actual diagrams and specifics of different approaches? Cool. All right, I'm going to go ahead and start hopping into it. So the first diagrams, the first difference I want to cover here is standalone service versus the per machine approach. I'm probably maybe going to have this cover pulled up a little bit as I'm going through it, just to make sure that I do like totally cover everything. Is so when we have a per machine approach, so you've got the client and you've got the backend service. This is not the rate limiter service. This is the one that wants to use some kind of rate limiting. You've got a load balancer in front of them. So you're going to have, you'll have a couple of machines. And so it's a horizontally scaled service. And so we are going to draw, we are going to draw it just like this. I'm going to post this in the chat afterwards as well. My draft, my pre-work, I'm going to make sure this is in the pinned comment afterwards. And I'll post this diagram that I'm currently drawing afterwards as well. So we've got our horizontally scaled service, and I think I'm going to draw a dashed line box around this whole thing as well. Show it's one service. You just have one backend service. So then we've got a request coming in, and then we are going to have it directed to one specific machine. And then the way that it's going to work is that it has a locally side deployed like instance of Redis, as opposed to having it like out as an independent database. So usually when you interact with the data store, you're going to have it like out, and they're all going to be sharing this one horizontally scaled out data store. But instead, we're going to have a locally deployed rate limiter per machine. So you're going to have something like this. You might recognize this little way that I like to draw things from machine learning data models or something like that, but it's like co-deployed with your machine. It's just like a Redis instance or something. And so it's an independent data store on each. And then in this case, you would not be getting exact numbers. This is for like DDoS protection. And you would just get like an even amount across the whole thing. It might make more sense to API gateways also have a built-in rate limiter, and so there's I don't know if you really do want to spread out the DDoS across all of your machines, or if you want to have it like blocked further upstream. But what I was getting at is that this is one approach where it'd have a bit more of a fluctuating. It wouldn't get you an exact number in this approach. But this is one of the things, it's a per machine rate limiter. The other one is, of course, where you have a standalone service. So we're going to go ahead and draw that. So got our service over here. It's going to come into your backend service. It's going to have that over here. Got the request coming in, and then you're going to redirect it to a rate limiting service. So we're going to have our own little rate limiting service. So this is the standalone service, and you would have something like sharded Redis, or you could even do DynamoDB. It depends on the use case. But for I'm currently just kind of thinking in terms of the DDoS protection approach. So these are both kind of drawn in terms of how I design something for DDoS protection. Maybe there's a more effective thing for DDoS protection than actually letting it fan out to all of your services. You would, of course, want to do the rate limit check before actually trying to do any processing of the requests. But that is my current thinking with how I'm kind of drawing these out. we'll cover the ones that are a little bit more low scale for when we get to some of the other use cases. But so standalone service, we'll go ahead and draw that out. I think you would probably use sharded Redis for this. So you have count thing. And then another great thing about Redis is that it can do CRDTs. So when I particularly actually like this, the standalone service approach for DDoS protection because Redis has those CRDTs, and the CRDTs are not going to give you exact counts. So that's like why it's like really good for those cases where it's a really high scale, but you don't need an exact count. Is that CRDTs can, although they handle the concurrent write issue, they do not handle the issue of, so you got this, and then this thing's going to check for, it wants to check whether or not to throttle it. And this is where the issue happens with CRDTs, is that you got the request coming in, and then if you get a dropped packet on the way back, if it gets killed here, it would think that it didn't properly hit the data store. And so then you can get a double count. It would retry to hit the data store. And then you would get your successful response back, but that would result in a double increment. So CRDTs handle concurrent writes. If you have multiple replicas for the same shard, they would be able to share their data, but you would still get this dropped write issue. So that's what I was trying to say about CRDTs with Redis. Very phenomenal for handling the scale, but again, you get that double counter approach. So it's not actually perfect for when you want to get an exact count. If you did want to get an exact count, I'd actually recommend storing the timestamps. Yeah. All right. I'm going to check on comments now. We've got our first two approaches. I think we'll go ahead and dive into more exact approaches next, but I want to check the comments we got in the chat. That is a great call out. Yeah, CRDT is short for conflict-free replicated data type. There's some further information about it in DDIA in a couple of spots. I guess they're kind of considered a little bit more advanced. They're database dependent, so you have to check that the database you're using actually implements them. They are only relevant for leaderless data stores. If it's a single leader one, then you can't have replicas. You don't have replicas of the leader, which is the one that you hit with the write operations. So Cassandra could have CRDTs. It doesn't have CRDTs in Cassandra, but you can actually, there's this article on Jepsen.io about rolling your own CRDTs with Cassandra, but DynamoDB doesn't have them. It's because it's single leader, like just straight up can't have them. Redis does have CRDTs though. So fun fact there for illustrating that further. All right, so I talked about the double counter issue. So what if you did want an exact count? Like for example, if you wanted to have exactly 20 accounts per day, if you wanted something like that, where it's really low volume, and you want an exact count, I think you would store them individually. I think I had a better example. I think it was, let's go ahead and say like 5 is a little bit less expensive than 20. So we're going to say that we now want to do 5 per day. So we're going to do something similar to this, the standalone service, because you can't get an exact count when you're doing the per machine basis. You can't get an exact count because these would then have to share their information across each other. Which is you're then reinventing the wheel of a leaderless data store. So you can't get exact counts with this. So instead, again, we got our data store. Let's talk about the schema really briefly. I'm jumping around a little bit, but so we're going to talk about the schema here, and then we can talk about the schema for how we would get that exact count on a standalone service. Okay, so got this. And this is fixed window approach. So what I'm coming up with here is it's under the fixed window algorithm. And so you would have either the user or you'd have the IP address. That's another key detail is, are you throttling it by the user or are you throttling by the IP, which is really important for DDoS protection because a user might roll 20 accounts. What if they've created 20 accounts on one IP address or something like that? So you can either throttle based off of the user, you can throttle based off the IP. If it's just for a multi-tenant architecture, if it's for a microservice architecture, you're just trying to do throttling of downstream services, we actually had to do that at Amazon, is throttle downstream services. We also have the service name instead. And then we're going to have a floored timestamp. I'll explain what that is. And then it's going to map to the count. So we're going to have, let's say that their username is UBSU, that's me. And we're going to have the timestamp. So it's going to be Unix epoch time. And we want to say, so this is on, we're going to say it's the example of the 5 accounts within 24 hours. So you would just round this down to the nearest 24 hours. So it's about 100,000 seconds in a day. So that would be 1, 2, 3, 2, 3. So it would be that number right there. So if I wanted this to be the closest day, we'd actually do that. So you're just doing the floor function on the timestamp. And so the key would come out to ubidesu underscore 167 a lot. And then it maps out to 3. And then if I make another account or I do another of whatever action it is, under that same day, get updated to 4. And then if I do something the next day, you'd have the count for 1, 2, 3, 10,000. What is that? 10,000. Let's do, there we go. That would be the next key. That would be the next key. Yeah. I don't think I have, what is it that's bought? Oh, no, it's, okay, that's the proper format. So it is actually going to be 0 and then 1. That's how the Unix epoch time is formatted. I actually looked this up off of a previous video because somebody was being very pedantic. And then so you'd have that. Yeah. Okay, I think I've got a couple of questions, but that's my explanation for how the fixed bucket one works, is that you're you have the things like this, and then within a certain fixed window of time, you can only go so high. So this would only go up to 5, and then you'd start rejecting requests. Let's look at the chat. We're at different backend service versus the common. Oh, okay. Well, so what it might scale better. It's a lower latency. You can hit your rate limiter with much lower latency in picture 1 because it's just local to your own machine. One, I think in Stanley Chang's book, he even suggested making a library, and so then it would actually be. So if you have a Java service, it's in Spring or Spring Boot. You just have a jar file or something of just making a rate limiter yourself with like a hash map or something. I don't think that would actually necessarily be all that much. I don't know if it would actually be faster than just using Redis itself, because Redis is incredibly fast. I'm pretty sure it's written in C or something, and it's you might as well just be using Redis or have a little daemon process running Redis. So this should be really fast. And then this one's gonna be a little bit slower. And it's, yeah, it's probably, I think the primary trade-off is latency versus precision and accuracy. Yeah. If anyone has any more input, feel free to share in the live chat or in the comments below, but I'm pretty sure it's just latency versus precision / accuracy. The IP approach can be problematic if 2 or more users working in the same local network. I think the user ID will be better. So yeah, it just depends on your use case. It depends on your use case. So for example, if you're trying to limit somebody from spinning up 1,000 accounts off of one IP address, that's why you would have like an IP approach. But if you're just trying to limit somebody from flooding, let's say, I don't know, Discord or LeetCode with comments, you could use a combination of IP do IP underscore user, or you would just do user. You would just do user because it would be, you'd hope that they're only posting off of one. So again, it just depends on your use case. If you're trying to prevent somebody from flooding your service or your website with comments, user would probably be a good idea. I mean, if they spin up like 20 different accounts though, and they're all working off of one IP address, I mean, that's another thing. It's you just want to specify with with your interviewer on what strategy you want to go with, or like what it depends on the use case for exactly what you're doing a rate limiting on. I didn't actually bring this up at the start. I should have. I actually received this problem in an interview before with Pinterest. So Pinterest actually asked me this question. Apparently they were impressed by how I covered multiple approaches. You only actually need to implement one in a real interview, of course. I went through a couple, and I think the guy that was interviewing me was like the staff level at Pinterest, and who was apparently impressed I actually covered multiple approaches. I never actually managed to clarify the scale numbers, and I even forgot to clarify. I was trying to cover the use case as much as possible, like push him like, is it DDoS or something? But he was trying to make it generic. And so he didn't actually give me a use case either. And I think I did leave it a little bit open like I am right now. Yeah, but that's a trade-off. You should try and push your interviewer to clarify. He just didn't want to clarify. I think he didn't have it planned out in advance, and so he was not giving me a solid answer. We can move on now. That's some context on doing this in an interview scenarios, is how you actually solve this in a real interview is I actually was able to get away with leaving it really open. Now for a exact count, so my interviewer actually did want an exact count. They were trying to push for an exact count on what they wanted to do. I learned during the interview actually that Redis also supports transactions. They're called anchors, and somehow that was important. I think I brought up the CRDT thing and how it was a little bit loose on the accuracy, and so he brought up anchors that would not actually properly solve it, I think. But yeah, he was trying to shoehorn a specific generalized solution, and I think he could pick up that he was doing that. Okay, so we talked about a schema for when it's a loose count, or when yes, this is a bucketed approach, a loose count. You can use Redis. I should clarify that the technology is Redis on the diagram. So that one is locally deployed Redis, and then this one is sharded Redis. And then you can do CRDTs with replicas, if you're doing replicas of each shard, you're able to do that. Okay, and then over here, the schema is going to be very different. We're going to go for, okay, so we're going to have either the user or the IP. So if you're just trying to limit my IP address to, let's say, 5 accounts per day. So I'm going to do localhost. That's not actually what you would have, of course. And then you would just have timestamp 167.0.0.0, 5,000, and you would use the IP or the account as the partitioning key. And then you can use this as the sort key. You can also use a Redis sorted set. I didn't finish filling this in. Okay, you can actually also do a Redis sorted set, and then with a TTL, that would mean that your old data would just go ahead and evict itself out of there. Otherwise, if you're doing DynamoDB is what I was feeling on this approach. So you got DynamoDB, and we would have a query that would roughly look like this. Fetch the 5 queries from Ubidesu with the greatest timestamp value. Are they all from within the past 5 hours? That would be past 24. And if so, then you would reject the request. You would just send back a false. It'd be like false, block it, and then you'd say, no, we're not gonna let you create the account. I see some questions in the chat. One quick call is, so for this, I was just trying to get an exact count. So this does definitely prevent, so you can retry, you can do retries off of the rate limiting service and up here, and it would always be with the same exact values. You'd take the timestamp at the time of receiving it over here. And there's other stuff you can do for deduping, but it's you have some action, got the timestamp at initial receipt of that action, you try and drive it through. And so it would be idempotent starting at the backend service. And so with your retries, it would only try to write the same exact values. If it's already there, it's not going to result in a duplicate record because it would dedupe on its own. And this also conveniently gave us a rolling window approach, which is kind of more favorable than a fixed window thing. You could, of course, set it up to in a fixed window scenario, but if the simpler query for handling this data, this schema would actually be in a rolling window format. I think those usually would be a bit more just like off of my own intuition. It just seems like you'd prefer to have a rolling window. It would like make the users question less, like why something's happening a certain way. Like towards the end of the day, of course, your throttling would tend to happen a lot more. And so the users would be like, why is it so hard to create an account right before midnight? And then right after midnight, you'd be able to create it just fine. And so if you get a rolling window, it would probably intuitively make a bit more sense to the users. All right, let's go ahead and answer some questions now. Cons in the first pick is you should also maintain the account across all instances. So you're talking about this one. And in this case, you, of course, do not have a means of limiting it properly. So let's say that you have, you want it to average out to no more than 500 within a window per user. And then we'll say that we have 5 instances over here. And so then actually, we're going to say 300. We're going to say 3 instances, just that it matches up with my diagram perfectly. I'm going to say that no more than 300 actions within a window per user. You got 3 instances, and then so you would say 100 max counts allowed per key for each instance. And so then probabilistically, you might max out one of the caches before a different one. And so then you would you might cut it off early. So you could even give a little bit more extra budget. You could say 120, or even you could even say 300 to a machine, and then your max would be 1500. But you could give them a little bit more leeway, like 120 max count per key. But still, one of them is going to run out before another. They can do retries. And so then you might get kicked on this machine, but this one will let the thing go through. But on average, the average amount that it would let you have through should be like 300 to 360. So it's you're not going to get your exact count in this case. You're giving up accuracy and precision of your rate limiter. You're not getting 300 on the dot allowed within the window when you're going with picture 1. And in certain scenarios, it might fairness might be a lot more important in some scenarios. It's I guess that's another wow, typing was awful there. So it's latency versus precision, accuracy. I think the best word is maybe fairness is what you're trading off. Latency versus fairness. Maybe there's some kind of other trade-off on top of latency. I can totally see latency as being a huge pro on this approach, though. Okay, next question. Is there a way to get actual IP? I remember reading due to NAT, usually ISP does not provide actual IP of user, but IP of the ISP during. I thought there was some way you'd get some kind of IP address of the user. I thought that you can do an IP ban. I used to really be into hacking, and I never did anything illegal, but I definitely did get a fair share of 403 forbidden messages, which is an IP address level ban. And then some websites weren't aware of this thing called Tor. And so I could just IP hop off of Tor and get new IP addresses. And I thought that was just the most hilarious thing ever. But I'm pretty sure you can actually get an IP address off the client. Otherwise, I'm pretty sure you can actually get an IP address. You can mask it. The client can mask it to a proxy or a Tor. It actually does kind of like show though, like it's Tor nodes self-identify, and then most proxies and VPNs they're blacklisted by services. You can actually, I think there's even probably some kind of like list of known proxy addresses and known VPN addresses that you can like buy off of the service or something to help you with spam prevention. Okay. Also, any approximate number you have in mind if Redis used for storage versus DynamoDB for latency? Or so Redis is going to have like much lower latency numbers because it's just reading straight off of RAM as opposed to disk. And I mean, I don't have exact numbers for whatever you're trying to limit the actions to is going to depend on the use case, and it's just something you have to specify with the interviewer. And I have one last question, then we can go ahead and move on to some other alternative approaches. Is the backend service the API? Is the backend service the API we are trying to rate limit? Oh, that's a good, okay, that's actually a good question. So that was one of my scenarios that was one of the use cases is throttling downstream services. Sometimes you want to do that. We had to do that at Amazon. So sometimes you do just want to throttle downstream services. It's to encourage them to cache your data. So in this one case, it was someone was at Amazon. There was this case where we wanted to, it was like mapping marketplaces to their IDs, or it was like mapping a merchant's account to its ID. And there's like only, we only had hundreds of some specific thing, and we would fetch them from an upstream service. But if we didn't cache them, we'd just be pounding that service with thousands of requests per second, where we only actually needed to do like a few hundred per day. Oh, string translations. Oh, that was it. That was it. So we had this upstream service where we'd give it a string ID and it would translate it to a specific language, such as English or Spanish or Mandarin or Hindi or something like that. And so we'd be like, here's the string ID, and then we'd get it back. And those, of course, never changed. They would change like maybe once a month at most. You would like change. So sometimes you did have to tweak the translation a little bit because it was just off by a bit, or we decided we needed to change the word choice a little bit for legal reasons. But then we could also manually force the cache to refresh. And then if we didn't cache those, we'd be hitting that string translation service thousands of times per second, where it should only be hundreds per day at most. And so that they would throttle us. They would throttle us, and if we didn't have it cached due to our own issues and own stupidity, we would have been hammering them with way more requests than necessary. And so they would actually throttle us to a certain rate to prevent us from taking down their service out of our own stupidity. But a lot of the time you wouldn't do that, and it would actually be, you'd be throttling it over here. You'd be throttling it coming from the browser to the backend service. But in that specific case, it is from backend within Amazon.com to backend within Amazon.com. Yeah, I was wondering if we want to call it, if we want to call it before rate limiting. In Alex Shu's example, I think he calls the rate limiter middleware before. Yeah, so sometimes the rate limiter is built into a API gateway, I think, and an API gateway could also be the load balancer. And so you could even kind of do a setup where, okay, here, I'll draw it. So you could even put your rate limiter service could be here, and then instead of a load balancer, it's an API gateway. And that one in its own could be a black box that internally it could even do something like this. And so then your API gateway could even look like, design an API gateway would actually be a fantastic interview question, I think, at Google, where you're supposed to roll your own interview question. So we're expanding it like I did on I think the payment gateway problem. And then like internally you might have a couple of machines in this API gateway service that just like internally have their own little go ahead and delete these, and I'm going to add. So we're going to have a request. It's going to come into the first machine, and it might have a localized instance of one of these, or it could even be the rate limiting service used within the API gateway could even be a standalone service of its own. So instead of this, you could even have it where so you have this, and then internally you could have, so it hits the gateway service. Say that we have 3 gateway service machines. There, we got that. Gateway service. And then you have something similar to this, where you could still have the gateway service calling a rate limiter service. And then the decision of, so it comes in, you hit your data store, and then it comes back. And then before it even hits your backend service, it could return that rejection straight to the browser without even touching your backend service. It's just handled over here in the API gateway. Yeah. Explain difference in usage between Redis and DynamoDB. Well, it's just different. I mean, you could even use Redis similar to this, where you have the timestamp and then you just use a sorted set instead. And okay, how I'm not super great with how the sorted set actually worked. I just know it's a skip list. And then I think it's a key to, wait, how does it work? Yeah, it's a key to a value, and then the values are what's in the sorted set, I think. And so it just similarly looks like, yeah, okay, I'll draw it, sorry. It still looks a little bit like this. And then the sorted set has to be charted in a similar manner to gaming leaderboard. Or no, you'd have a certain chunk of IP addresses to each one of the stores when you're doing it with the sorted set. And then you would have the range of timestamps for the specific ones within that shard would all be sorted by the sorted set. And then so Redis is a key value store. And so the key would be IP address, or it could be your username, and then it would be mapping to this. And so the alternative schema is that it's the username. And so we have me making one there. I'm pretty sure it looks something like that. And then if you have multiple, then you have my next request coming in, let's say 10 seconds later. And so then that would be 0. There we go. I don't know. Those keys would not be uniquely identifying. I gotta think that through a little bit more. That didn't actually make sense. Look at Alex Shu's gaming leaderboard chapter for how sorted sets work, though. I'm sure that's that. I totally read somewhere that you can use a sorted set to do something similar to what I was describing with DynamoDB. Okay, where are we storing? Oh, and then so let's say that's in volume 2, by the way. Volume 2, gaming leaderboard chapter. Oh my God, my typing is so atrocious today. Yeah, I definitely did not explain the Redis sorted set for this specific use case. I forgot to look it up beforehand. But it would explain how to do whatever the heck I was trying to explain over there. Where are we storing rate limiting rules? Yeah, nice. Yeah, so I do. So you either have a flat rate for everyone. You could have just a flat rate for everyone, like just everyone has a limit of 5. That's what we've been doing so far. But you could also do client-specific rules. So, for example, at Amazon, when we had an upstream service that was that throttles stuff, if you were a bigger service, you might need to call them a little bit more often. Like, for example, if you had a lot more strings than other services, then you might request that the string translation service gives you a bigger budget for calling them per day. And so you would, of course, need to store that somewhere. And so I do actually have that somewhere in my design that I was going through beforehand. Is you could do a business rules engine, or you can just cache the number exactly. So if it's just an exact number, you can just go ahead and cache that. Let's go ahead and draw that. It's going to be standalone service, and it's so in this case, I would expect that if you're doing client-specific values, you're probably going to want to do a standalone service. So the ones up in this row are for doing per machine rate limiter on that row. And then on this row, we have the standalone service rate limiter. Oops. I want that to be in all caps. So this row is standalone service rate limiter. And now we're going to have client-specific budget and a standalone service rate limiter. And this is real. This is a real thing that we had to do for a thing at Amazon, is that sometimes you would give specific you might have like tiers, is how I was drawing it somewhere, is that you might have like a gold tier, silver tier, platinum tier service. You can map that to different budgets that you might give them every day. If you're doing like client specific budgets, then you're probably going to want an exact number. And then so we still would have account stored over there. You might use, well, so if it's a budget and it's like hundreds, so you don't want to aggregate, you don't want to do that DynamoDB aggregation if it's a number greater than like 5. It's actually this one's not too, so I have it partitioned so that it would not do a scatter gather. This is not set up for scatter gather. That's what I was checking right now. But still, even if you're avoiding scatter gather, if you're reading off 100 rows and aggregating them, I think that would still be rather expensive. And so you probably still want to have the CRDT approach. Although you might get this counter approach. I meant counter. When you're using a counter instead of storing the individual timestamps, it means that you can't make it idempotent. So we don't have idempotency when we're doing this counter approach. But if you're giving them a budget, you're summing up these amounts that are greater than like 100, it'd be expensive to do the key range query thing that we were doing with DynamoDB. So there's going to be a little bit of opportunity for double counts, but I don't think it would happen frequently enough that it'd be a huge issue. Anyways, let's keep going. Is that so? You have that, and then you have this client specific budget, and if it's a small number, if there's only a couple of numbers and the rules aren't sophisticated, you could keep those this budget mapping local to it's the budget mapping. It could even be a config file. It could just be an XML file. It doesn't even have to be Redis. It could just have a budget mapping. And let me go ahead and write out what that means. So it's either config file. You could have Redis, and it's just up to hundreds of values, of client-specific values. If you're going to have more than that, or you have compound rules, so where you really would start to see the rules become a great example of where having lots of rules means that you can't do something like this is with a metrics monitoring and alarming service. So for example, the stuff that sets off your pager at 3 a.m. if you have one of those, they have a lot of rules, a lot of very specific rules. And so that's when you might want to use a business rules engine. So first you'd have, a localized budget mapping if it's just hundreds, but if it gets big enough, you would need to pop that out into its own standalone thing that looks at a whole bunch of rules. And so then instead you're going to have a business rules engine. There's a bunch of different stuff that can do this. It could be rules, I think is one of them, DROOLS. So rules. So first it was you had the config file approach, another local Redis store. Just on the rate limiter itself, you have the local Redis store. If it's big enough, though, you could use a business rules engine, and rules is one example. Google Cloud Platform actually rolled their own, I think it's just called Rules Engine alone. So GCP has Rules Engine, I think is what it's called. And so I think first you would go ahead and get the count. So you got the request coming in. Hey, can it actually, can we actually give them a response? Should we actually do any further computation? We're asking this one, hits data store, returns the count from the data store. And then you pass that count and user ID or whatever their tier is over to the business rules engine. And then the business rules engine gives you a yes or no response. And then you can go ahead and return that to the backend service. If it's a no, you do no further computation and you return it straight to the client. You're like, nope, I think it's 429 is the status code. You're just like 429. Nope, we're not giving you an answer. Otherwise, you make whatever other API calls or further expensive computations, and you go ahead and give them a proper response. But a business rules engine is what you do. Yeah, okay. And I think I did actually do a better schema somewhere on that in my pre-work. I did actually think about a business rules engine. There was, was it like a tier? Is that what I called it? Oh, it might have been in my other file. And somebody has confirmed that, yep, it's a 429 response. Thanks. Okay, I think, yeah, no, I can't figure out where the heck I did the full schema of tiers of service. Oh, well. Okay. I think I wanted to cover, oh, it was another rolling window approach. There's one more rolling window approach that I could think of. So what if you did have hundreds and you wanted to do a proper window? I was thinking, I've never seen anybody talk about Flink. There's another way to do rolling window that's really obvious. It's particular. I particularly see Flink, I think, come up with ad click aggregator. If you want to have counts in real time, is that another approach could be, I believe, Flink. So you got your service. And for each of these, you're going to have to do a write before you do a read operation. Is that first you would write, you'd increment the count, or do the whole thing within a transaction is that you would do a read. Hey, can I increment it? If so, then you increment it. So I think you would do a read and then you would do a write. Yeah. So one, read current count, and then two, write, you either update the count or you would, in the case of DynamoDB, you would write a new record. So now let's talk about our new approach that involves Flink. So you got this backend service, and then we've got our rate limiter stuff. So you are going to have some kind of Kafka stream in order to accept any write operations. And then you're also going to have Flink. We're going to have Flink. Flink will be reading off of our Kafka stream. Let's round that. There we go. And we've got a Kafka stream. Wow, it rotated it for me. I didn't actually mean for that to be rotated. Okay. And if you are allowed to do an extra action, you would write it when you are allowed to. But first, we're going to do a read. We're going to ask Flink, hey, are they, what's the count for the rolling window? Flink will give you an answer. And if it's a no, you don't add an event, and you just go ahead and do your 429 straight over to the browser. But if you are, you would first do your write operation to Kafka. Hey, I'm going to do a write operation. And then you would go ahead and you'd call your other services. You would do your computing. There, it's like you're calling some other service. And then you do your computing. And you would give them a proper response over there. Yeah. I am just so curious why nobody has brought up Flink. I'm thinking maybe it's a naive approach somehow. But this is another way to do a rolling window approach for rate limiters, probably with Flink. Maybe if it's like a DDoS, then it would probably not scale well, possibly with Flink. I'd imagine for DDoS protection, you probably want to do something like this, or like within an API gateway before it even hits the backend service. But if it's something lower scale, but still has a high count, like for example, limiting your users to 1 hit per second, that was one of the examples, is like, what if it's Discord and you don't want to have who had that example? A user can send only 1 message per second. That's like spam protection, and Grokking actually had that example. I'm trying to cite my sources, and like I'm trying to stand on the shoulders of giants, but it's a good idea to credit people for their work and their own ideas. And so I wanted to fish that out. Grokking had that idea. So you're trying to limit somebody to 1 message per second on average over the course of a day or something like that. And it would make the most sense, I think, to do a rolling window for that approach, as opposed to a fixed daily bucket where you would suddenly see all the rate limiting happening at the end of the day. And so you'd have a spike in spam at the start of the day, and then you'd see all the rate limiting happening at the end. That would make a lot of sense. You'd want to have like a 24-hour rolling window or something like that. And so I think Flink would make a lot more sense. And that would be very different than DDoSing. DDoSing is we're just totally slapping it with tons of nonsense. And you're trying to shut down the backend service itself, while spam is a lot more different, where it's like maybe somebody going through 1,000 different Discord channels with one of those channel invites. And so it's not quite the same volume that you'd have a proper DDoS attack. So I think this would actually make sense for the case of like Discord spam protection. Okay, I see a question in the chat. Let's go ahead and answer that. What about some real life optimizations like request collapsing or client side? So this was actually specifically called out by one of the resources called this out. I think it might have actually been Alex Shu, is that you don't want to do client side rate limiting because it's like trivial to get around it. Is for example, if you do rate limiting within your React.js code, I'm a front-end engineer. I spent at least 3 years writing React.js. It's trivially easy for them to reverse engineer the API calls that it's supposed to make. So if you're doing the rate limiting off of within the React.js application logic, what I can do is just watch the API calls that are happening in order for me to make a post on Discord. I can just run Wireshark, or even if I'm running Discord right within the browser, I just pull up the network tools. So that would be like this. And then I can just go over the network tab and I can look at whatever the heck comes up here, and I can replay it on Postman, completely circumventing the application logic completely. So you don't want to do client-side rate limiting. It's trivially easy to circumvent. I mean, it would catch enough fools that you would see a benefit if like you'd see some benefit from doing that, but it would not manage to prevent the most determined of malicious end users. So some benefit, it would not deter. You'd still be able to get around it if you're really determined, though. What about some real life options? So I don't know what request collapsing is, though. I actually don't know what that is. I'm going to look it up. I want to make sure I cover my other approaches. Feel free to share anything in the chat beforehand, and I can put it in the text file too, or you can even post links in the comments below the video when I wrap it up to elaborate what you meant by that. I haven't seen that term before, though. I'm really interested in it. Okay, did I manage to cover all of my approaches? So we got the business rules engine. I did talk about that one. I went over Flink. I talked about the DynamoDB key range query. I talked about standalone service. CRDTs are super relevant for when it's a big counter and you're doing DDoS protection, possibly. Yeah, this one might also be really good for DDoS protection, but you would have you do an API gateway and you'd have it come from there first. Another one, another strategy for rolling windows, if you just have several buckets and so you still have discrete intervals, but you retrieve multiple at a time. So like, for example, if you're trying to limit it to X amount of operations within 15 minutes, you could do 5-minute buckets and retrieve 3 of them. So that's another approach. Okay, he explained what request collapsing is. When multiple clients are asking for the same thing, instead of computing and sending the response, store their. Oh, that's like a caching trick. Yeah, if you're asking for the same thing, just store the pre-computed response. Yeah, that's like that reminds me of dynamic programming. So I wouldn't call that a rate limiting solution, but I would call that that would be a really cool optimization. I've never heard of that before. That's really awesome. Find all the requests and send only one request to the server and then use the response. Yeah, okay. And so if you have I see what you're trying to explain here. So if you have wow, it's not working great today. Cool. So you have your backend service, and then we say that there's very expensive service over here. Very computationally expensive. So for example, with Google, sometimes there's stuff that requires, for google.com, when you're doing a search, sometimes there's like a semantics thing. I've even heard of a lot of search engines actually have a knowledge graph. And some of the results require doing special computations with a graph database that's used for the knowledge graph. And it has to do some kind of like BFS style traversal that's like super expensive and super latent. And so they actually will cache that approach, the query off of the graph data store. So this could be like a graph data store upstream. And then you have a certain request that requires making that call to the graph database. You would of course want to cache this response off of it and never call it again, because graph databases are super expensive for calling, because they do those like recursive queries. It's like OLAP, but possibly even more expensive. Maybe not. It's like on par with doing a full table scan. You don't want to do that. You don't want to be calling graph databases very often. And on top of that would still be a very latent response. And so you would cache the response from the graph data store into a local data store like Redis. Say medium. Nope. To just cache, and you can even do if it's a SQL query, you can just do a key of the exact query could be that you're going to submit is you just use that as the exact query as the key. The exact query becomes the key, and then you just store as the value is like the records. So if it's like 3 to 5 records, you just inline it, where it might have been super expensive to actually get those 3 to 5 records. Yeah. Okay, I think I covered all the approaches that I wanted to. I'm going to, of course, post my pre-work onto the pinned comment, as well as what I've actually ended up drawing here today throughout the session. I'll distinguish them from each other, and I'll put the text file in there too. All right, I'm doing any last questions before I wrap it up, but yeah, you guys are free to drop off. What is the difference between upstream and downstream? So you have, I can draw this one too. So this one would be upstream from this one. This would be a downstream service. So when you first receive it, actually, you can think of it in terms of data flow. So this one could actually sometimes be a downstream service. It depends on when, yeah, it kind of depends, but downstream is, if you're calling a service to retrieve data from it, that one is upstream of you. So you got your browser, and you got some kind of service over here. And let's say that you want to fetch some data from a different service. So this is some other service, you want to fetch data from it. So you're like, hey, give me some data. That one I think is upstream from you. But if you're going to write some data, so if you're going to write some data, well, so if you pass data to that data store instead, then I think they would become downstream. So you're fetching data, so you are downstream from them, because it's a read. You want to read data from them. But if instead you were passing data to them, and you're instead like, hey, the user's making this post, you got to store it for me, I think that would make them downstream, although you would typically want to have that stored yourself, and then you might do some change data capture. Let's break that out. So first we got the read. So doing a read off of this one. And so then this one I believe would be an upstream service, and then this one would be a downstream service. If on the other hand, you were doing a write to a database. So for example, you had your own database, it's the post data store, starting posts in here. Got this. And it's the post backend service. So you write your post to it, and then you're doing some kind of change data capture like this. You might even stuff it into a stream or something. This is based off of a real production service that I have seen. And then you got some kind of other task runners that are stuffing this off into, let's say there's a different backend service where you then have reads happening. So we got, so you're copying this, there's some task runners and they stuff it into a replica of your post data store. So now you've got a post data store replica. They're replicating your data. Maybe they're going to do a bunch of OLAP or something, and then you got this other data store and it's reading off of it. So the upstream and downstream services that I want to talk about here are this one and this one. And then we've got maybe something else where they're doing reads. So this guy wants to read that replica. Well, this data store is downstream from this one. This one's the source of truth. This guy is upstream and this one is downstream. So you've got your upstream service and then you've got your downstream service. The data is flowing down the stream. That's how you can think about it. And so similarly over here, you're downstream because the data is flowing. This is the source of truth and it's flowing down. So you're doing a call that's going up, but it's the data is originating up here. And so it's like the data is flowing from this service down to here. You have stale data relative to them. You're pulling it down the stream. Yeah. Okay, I think we're good. I'm going to zoom out so you can see the final drawing that I have over here. So this was a tangent on API gateway. We had per machine rate limiter. We had standalone services. Talked about client specific budgets with a standalone service. We went off on some tangents over here. This was another pretty solid approach though for a standalone service. Yeah, all right, I'm pretty happy with this coverage. Thanks for watching, guys. I'll let you go. If you have any other further questions, feel free to drop them in the comments below the video or in the Discord channel. Yeah, thanks. See you guys.